Okay, number 17 says negative 6m squared minus 13m plus 15. And I don't like this first term to be negative, so I'm going to start by factoring a negative out. That's going to flip the sign of everything. Okay, now what I'm going to do is I'm going to multiply 6 times negative 15, and I'll put that number off on the side, and it's negative 90. I'm looking for factors of negative 90 that add up to positive 15. So I think it's 18 and 5. So I'm going to go, this is negative 8 or positive 18 and negative 5. These multiply to 90 and add up to positive 15. And I was able to zero in on that, but you might have to actually start listing the factors of 90 until you find the one that gives you that. But now I can break up this middle term into those two things. So I have 6m squared plus 18m minus 5m minus 15. And I'm going to group these two as if they're a separate problem by grouping. And I'll have 6m times, here, let's do a negative out there. And 6 times, this is m plus 3. So I'll put a negative 5 out here. And that, if I were to distribute through, we'd get that and that. So this is my common factor of m plus 3. And we have 6m minus 5. Now that's all, that negative goes there. So that's a lot of work, but it helped us to find this middle term by looking for factors of this that gave us that. And then we just factored by grouping. Number 18 says negative 15y squared plus 17y plus 18. Now I personally don't like this negative, so I'm going to factor it out. And that flips the sign of everything in there. Now, the product of these two numbers, I'll just grab a calculator. 15 times 18 is 270. And it's a negative 270. So off on the side, I'll write negative 270. Now I'm looking for factors of this that will give me, this is a negative, so I have to look for factors that give me a difference of 17. And if you're not sure, you just have to start doing this, like 270, that's not going to do it. 2 and 135, that's not going to do it. 3 and let's say 90. 4, let's see if 4 goes into 270. Nope. 5. And divided by 270 is 54. And let's see, 270 divided by 6 is 45. I'm just using a calculator. 270 divided by 7 doesn't work. 270 divided by 8 doesn't work. 270 divided by 9 is 30. And 270 divided by 10 is 27. And I will stop there because I actually happen to see it. That's going to give me my difference. And you may have just realized that right off the bat without having to draw all of your factors. But I have to put the negative on the 27 and the positive on the 10 because they need to add up to a negative 17, and they have to multiply to that. Okay, now I'm going to break up this middle term as this. So I have 15y squared plus 10y minus 27y minus 18. I'll break up these two by taking out a 5y, and we're left with 3y. This negative is going to stick on there. I'll put that later. But this will be 3y plus 2. I'll put 3y plus 2 again. And then I have to put in a negative 9 here so that when I multiply, I get to that. Just double check. Negative 9 times that is that. Negative 9 times that is that. So now my 3y plus 2 is common. And I have 5y minus 9 left over. And that negative gets written out there. Number 20 says 8k squared plus 34k plus 35. Again, I'll multiply 8 times 35. I'm just going to grab a calculator, and I get 280. So positive 280. So because it's positive, I'm looking for factors that add up to 34. And if you're not sure, just start listing them out. 3 doesn't go in there. 4 is 75. I'll just grab a calculator. Is 56. 28 divided by 6 doesn't work. 28 divided by 7 is 40. Let's see. 280 divided by 8 is 35. 280 divided by 9 doesn't work. 280 divided by 10 is 28. Let's see, 280 divided by 12. No, 280 divided by 14 is 20. I'm going to stop there. I'm looking for factors that add up to 34. This adds up to 281, 142, 74, 61, 47, 43, 38, and 34. That's it. So I'm going to stop there. So this I'll rewrite as 8k squared plus 14k plus 20k plus 35. These are my middle two numbers. I'll group these two by factoring by grouping, by taking out a 2k, and that'll leave a 4k plus 7. So I'll know this is 4k plus 7. Then what I put here to multiply to that must be a positive 5. So now I have 4k plus 7 and 2k plus 5. And that's it. And you can always FOIL your answer to see if it comes back to the original to check your work. Okay, number 21 says 20k squared plus 47k plus 24. If I multiply my two outer numbers together, I get 480. It's a positive. So I'm looking for two positive factors that add up to 47. And you can start listing these out. You can just use a calculator to get these. 96, 6, 480 divided by 6 is 80. 7 doesn't work. 8, it's got to be 60. 9, let's see, I don't think 9 works, but I'll double check. That doesn't work. 10 is 48. I don't think 11 works. Let's see about 12. 12 is 40. I don't think 13 works. 14 doesn't work. 15 is 32. And there it is. Right? That adds up to 47. That's what we're after. So I'm going to break up this middle term like this. This number are those as found from this. Okay, now I'm going to factor this by grouping. Here I'll take out a 5k, and it leaves behind a 4k plus 3. And here I have to put, let's see, a positive 8. So now I have 4k plus 3 and 5k plus 8. This is a really long method to go through. And actually, if I was doing this for real, I would not have written all these factors, because I know I'm looking for factors fairly close together to get to 47. Because one of the factors can't be too large, right? So you have to have two kind of smaller, well, each of your factors has to be lower than 47. So like up to here, none of these factors are even possible, because each one of these factors is bigger than 47. They can't add to 47. Okay, number 22 says 27z squared plus 42z minus 5. Okay, when I multiply this and this, I get negative 135. When it's negative, one factor is positive, one's negative. So when I add them together, I'm actually subtracting. So I'm looking for factors that have to subtract to 42. So you can start listing. 1 and 135. 2 doesn't work. Let's see, 3. And I'll just use a calculator. I get 45. 4 doesn't work. 5, I'll use a calculator. I get 27. Well, here, I'll stop right here. This is what we're after, because those are the two factors that multiply to this and give us a difference of this. And I have to put my signs on here. This has got to be a positive 45 and a negative 3, not the other way around, because I have to add up to a positive 42. So this is 27z squared minus 3z plus 45z minus 5. Factoring this by grouping, I'll take a 3z out, and I'll get a 9z minus 1. So I'll put that down again. Then over here, I have to put a positive 5. So that's so when I distribute, I get to there and to there. So my answer is 9z minus 1 times 3z plus 5. Okay, number 23. We have 15a squared minus 22ab plus 8b squared. Okay, when I multiply my two numbers together, 15 times 8 is a positive 120. You can use a calculator to do that if you want. So because it's positive, I'm looking for factors that add up to 22. So you can start listing them. 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20, 8, and let's see, 120 divided by 8 is 15. I'm going to stop there. Well, let's do 10. 10 and 12. I'm looking for a sum, of 22. So that's it, right there. So I got to put my signs on. Negative times a negative is positive, and this adds up to negative 22ab. So this is 15a squared minus 10ab minus 12ab plus 8b squared. Grouping these together, I can take out a 5a, and that leaves a 3a minus 2b. So I'm going to leave a big space, and I'll put 3a minus 2b down again, because whatever you leave behind here has to be left behind there. Then here, I have to put in a negative 4b. And just double check. This times this is this times this is that. So my final answer is 3a minus 2b times 5a minus 4b. Okay, number 24 says 15p squared plus 24p cubed plus 8q squared. When I multiply these together, I get a positive 125. And I'm looking for factors, because it's positive, that add up to 24. And I just did these same factors, but I'll do them again. 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 24, 6 times 20, 8 times 15, and 10 times 12. And I'm trying to add up to 24. And I don't see, none of these add up to 24, unless I'm missing something. Nope. So this is prime. Okay, number 25 says 36m squared minus 60m plus 25. You know, there's a shortcut to this. When this is a perfect square, when this here is a perfect square and this is a perfect square, well, you know, before I show you that shortcut, let's just do it this way. 36 times 25, actually, I'm going to show you the shortcut. This is the long way, is too long. I'll put this 6m here, I'll put this here, and I'll put this sign here. Now, this may or may not be the answer. You actually have to check it. So I'm going to check it like this. 6m minus 5 times 6m minus 5, and I'll FOIL it. So I'll get 36m squared. The outer is negative 30m, the inner is negative 30m, and the last is positive 25, and these add up to my negative 60, so this is the answer. Now again, I'll explain that shortcut better later, but this is the process. I took the square root of this, put it here, I put this first sign, put it there, I put the square root of that there, and then I checked my answer to make sure it worked. Number 26 is 25r squared minus 90r plus 81. Again, this is a perfect square and this is a perfect square, so I think my answer is a perfect square. I'll put the square root of this here, this sign, and the square root of this. This may not be the answer, so I have to actually check it. The first is 25r squared. The outer is negative 45r. The inner is negative 45r. And the last is positive 81. And these add up to negative 90r, which is what we had. So this is, in fact, the answer. Number 27. 40x squared plus 1xy plus 6y squared. So the product of these two outer things is a positive 240. I'm looking for factors of 240 that add up to 1. Well, there's not going to be two factors that add up to 1, so this is prime. Number 28 says 14c squared minus 17cd minus 6d squared. Okay, the product of these two outer numbers, I'll just use a calculator, 14 times 6 is negative 84. Because it's negative, one factor is positive and one is negative. So when I add them up, I'm actually subtracting. So let's list the factor pairs. 1 and 84, 2 and 42, 3 and let's see, 84 divided by 3 is 28. 4 and 21, there it is. That's our difference. So I'm going to just stop there, even though there's probably more factors. I'll stop right here. And I'm going to put the negative on the 21 and the positive on the 4 because these have to add up to a negative 17. Okay, so I'll have 14c squared plus 4cd minus 21cd minus 6d squared. Oops. Okay. I'm going to group these first two together by factoring out a 2c, and I'll have a 7c plus 2d, and I'll leave a big space and put 7c plus 2d down again. And then here, this has got to be a negative 3. A negative 3d, actually. And just double check. Negative 3d times this is that, negative 3d times this is this. So my final answer is 7c plus 2d, that's the common factor, times 2c minus 3d. And you can always FOIL to check out that it comes back to that. Number 29. 6x squared z squared plus 5xz minus 4. The product of the two outer numbers is negative 24. Because it's negative, I'm looking for factors that give me a difference of 5. So 1 and 24, 2 and 12, 3 and 8, there it is. This gives us a difference of 5. So I'll just stop right there. Even though 4 and 6 is possible, but I didn't need to do that. I need to put the positive on the 8 and the negative on the 3 because these have to add up to positive 5, not negative 5. So I'll write this as 6x squared z squared minus 3xz, whatever that is there, plus 8xz minus 4. Grouping these two together, I can factor out a 3xz. And that leaves behind a 2xz minus 1. So I'll leave a big space and I'm going to put 2xz minus 1 down again. Then I'll think about what I put here so that when I multiply, I get back to those. And it looks like a positive 4. So my final answer is 2xz minus 1 times 3xz plus 4. Okay, number 30. It's 8m squared n squared minus 10mn plus 3. The product of these two outer things is 24. So the product's got these two factors have to add to 10. So we have 1 and 24, 2 and 12. That won't do it. 3 and 8, 4 and 6, and that'll do it. So the signs are negative on both. We got to multiply to a positive, but add up to negative. So I'm going to rewrite this as 8m squared n squared minus 4mn, whatever that is, minus 6mn plus 3. These two numbers are that 10. Now I'll break this up. I'll factor out a 4mn, and that leaves behind a 2mn minus 1. I'll leave a big space, and I'll put 2mn minus 1 down again. Then I'll think about what has to go here so that when I distribute, I get back to those. And it looks like a negative 3. And just double check. Negative 3 times this is this, negative 3 times this is this. So my final answer is 2, let me write that better, 2mn minus 1 times 4mn minus 3. Number 31. Oops, what did I just do? 24x squared plus 42x plus 15. Now, I'm not going to multiply these two out yet because I'm going to get a huge, ridiculous number. Instead, I'm going to take out the GCF. It makes my problem a lot smaller and easier to manage. Now, when I multiply these, I get 40. I'm looking for factors of 40 that add up to 14. I'm not going to bother listing them all out. Oops. Because I think that's pretty simple to see. So I have my 3 sitting out here, and I'll write 8x squared plus 4x plus 10x plus 5. I'll group these two together as if they're a separate problem. I have 2x plus 1. I'll leave a big space and put 2x plus 1. And then I'll put the positive 5 out here, because that multiplies out to that, and that multiplies to that. So I'm left with 2x plus 1 times 4x plus 5, but don't forget that 3. Number 32. We have 36x squared plus 18x minus 4. Now this is not a perfect square because it's negative, so I can't use that perfect square thing, but I can take out a GCF. So let's start with that. 2, and I have 18x squared plus 9x minus 2. When I multiply my outer two numbers together, I get negative 36. Because it's negative, I'm looking for a difference of 4. So how about positive 12 and negative 3? So I have the 2 sitting out there. I have 18x squared plus 12x minus 3x minus 2. I'll group these two together by taking out a 6x. And I'll have 3x plus 2. I'll put a big space and put 3x plus 2 down again. Then I'll think about what I'll put here so that when I distribute it, I get to those, negative 1. So my answer is 3x plus 2 times 6x minus 1, but don't forget that 2. Okay, number 33 says negative 15a squared minus 70a plus 120. Okay, it looks like all of these are divisible by 5. And this is a leading coefficient, it's negative, and I don't want it to be. So I'm going to factor out a negative 5. And that's going to make this a positive 3a squared, a positive, let's see, 14a, and a negative, 5 goes into 12 twice, 24. Okay, now, I'm going to multiply this times this and we'll get negative 72. Because it's negative, I'm looking for factors, because one's positive and one's negative, that gives us a difference of 14. So I'll just start listing them. 1 and 72, 2 and 36, 3 and 24, 4 and 18. What is it? 18, 36, yeah. 18. 5 doesn't go in. 6 and 12, 7, 8. Let's see. 8 goes in there 9 times. Okay, and that's it. So now I'm looking for a one that gives me a difference of 14. There it is. So I need to put the positive on the 18 and the negative on the 4 because these need to add up to positive 14. So I'll rewrite this as negative 5 times, this is 3a squared minus 4a plus 18a minus 24. These are my 14a, and I got those from there. I'm going to factor these first two as if they're a separate problem, and I can only take out an a. So I have 3a minus 4. I'll leave a big space, and I'm going to put 3a minus 4 again, because whatever I leave here, I have to leave here. And then I'll think about what I put here, so when I distribute, I get back to those. It looks like a plus 6. So this is going to be 3a minus 4 times a plus 6, and don't forget about that negative 5. Okay, number 34 says, well, let's do 34, says negative 12a squared minus 10a plus 42. Well, these are all divisible by 2, and the leading coefficient's negative, so I don't like that, so I'm going to pull out a negative 2. And that's going to leave a positive 6a squared, a positive 5a, and a negative 21. And I'll multiply these two together, and I'll get negative 126. So I'm looking for factors, because this is negative, that give me a difference of 5. So 1 and 126, 2 and 63, 3 and 42, 4 doesn't go in, 5 doesn't go in, 6 goes in 21 times, 7 doesn't go in, let's see, 8. I'm going to use a calculator. 126 divided by 8, no, it doesn't work. 126 divided by 9, that works. 9 and 14, and there it is. That's our difference of 5. So this has to be a positive 14 and a negative 9 in order to give us a difference of positive 5 and a product of negative 126. So I have 6a squared. This 5a is now going to become negative 9a plus 14a minus 21. I'll break up these first two. I'll factor it by taking out a 3a, and that leaves 2a minus 3. So I'll leave a big space, and I'll put 2a minus 3 down again. Then I got to put a positive 7 here so that when I distribute, I get back to those. So this is going to be 2a minus 3 times 3a plus 7, and don't forget about that negative 2. Number 35, 11x cubed minus 110x squared plus 264x. Well, I can see that they're all divisible by x, and I'm going to use a calculator to see if it's divisible by 11, and it is. So I'm going to take out 11x. And that's going to leave behind x squared minus 10x plus, let's see, 264 divided by 11 is 24. I don't have a leading coefficient, so I'm just looking for factors of this that give me a difference of 10. So negative 6 and negative 4. So I have x squared, well, I can jump right to it. X minus 6, x minus 4, and don't forget about that 11x out there. Number 36. We got 9k cubed plus 36k squared minus 189k. Well, I know they're all divisible by k, but I think they're divisible by 9 as well. 9 goes into 18 once and that 18 twice in that one. So I'm going to factor out a 9k. That leaves behind a k squared plus 4k minus 21. There's no leading coefficient here, so I don't need to factor by grouping. I'm looking for factors of negative 21 that give me a sum of 4. So 7 and 3. So positive 7 and negative 3. That multiplies to 21 and adds up to positive 4. So my 9k is out here, and I'm going to have k plus 7 and k minus 3. And that's it. Number 37. We have 2x cubed y cubed minus 48x squared y to the 4 plus 288 xy to the 5th. Now they're all divisible by 2. When I look at the x's, we have a 3, a 2, and a 1. 1 is the least, so it stays 1. When I look at the y's, I have a 3, a 4, and a 5. 3 is the least, so this is to the 3rd. Actually, you know, well, I'm going to put that in red. 2xy cubed. Okay, now this gives me a 1 and a negative 24xy and a positive 144y squared. I'm going to reorder this because I want this term to be in front. It's just a little easier for me. So I'm going to write 144y squared minus 24xy plus 1. Okay, now I'm looking for factors of 144. Well, this multiplies to 144, right? So I'm looking for factors that add up to 24. So negative 12 and negative 12. So I'll rewrite this as 144y squared minus 12xy minus 12xy plus 1. And I'll group these two together as if they're a separate problem. See, these were that number right there, right? I'll group the first two together, and I'm going to pull out a 12y. And that's going to leave behind a 12y minus x. So I'll leave a big space, and I'll put 12y minus x down again. Then I'll think about what I need to put here so that when I distribute, I get back to this, and it's going to be an x. A negative x, actually. So my final answer is going to be 12y minus x times 12y minus x, and then don't forget this, which is 2xy cubed. Actually, another way to write this would have been like this. 2xy cubed times 12y minus x quantity squared. That might be a little more simple. That's it. Number 38 is 6m cubed n squared minus 24m squared n cubed minus 30 m n to the 4. So they're all divisible by 6, and they all have at least an m to the 1 and an n to the 2nd. So that's the GCF. It leaves behind an m squared minus 4mn minus 5n squared. I don't have a leading coefficient, so I don't need to factor by grouping. This is just going to be m like this, and I'm looking for factors of 5 that add up to 4. So negative 5 and positive 1, and don't forget the n. Oh, we're not going to write 1n, that's just going to be n. So this will be m plus n, because we want to make sure we're simplified. That's it. Number 39. We have 10 times k plus 1 squared minus 7 times k plus 1 plus 1. And let's do this. Let's let x equal k plus 1. And now, so what we have is 10x squared minus 7x plus 1. I'm going to multiply my two outer numbers together and get a positive 10. I'm looking for factors of 10 that give me a sum of negative 7. So negative 5 and negative 2. So I'll rewrite this. And I'll group these two together as if they're a separate problem. So I have negative 5x, and we have 2x minus 1, or plus 1 actually. I'll leave a big space and I'll put 2x plus 1 down again. Oh wait, I'm sorry, this one, yeah, that's right. 2x plus 1 down again. And let's see, we have, sorry, I don't know what I was doing here. That's my mistake. That's a positive 5x, and this has to be minus 1. Sorry if that confused you. Okay, now, what I need to put here is a negative 1. That way, when I multiply here, this becomes a negative 2x and a positive 1. So this, I have 2x minus 1 times 5x minus 1. But the problem is, x is not a part of the original problem. Now I'm going to have to replace x with k plus 1. So what I have here is 2 times x, which is k plus 1, minus the 1, times 5 times x, which is k plus 1, minus the 1. So what did I do there? Okay? This will distribute, and I'll get 2k plus 2 minus 1. This will distribute, and I'll get 5k plus 5 minus 1. Finally, simplifying, we'll get 2k plus 1, and we'll get 5k plus 4. And that's it. Number 40 is 4 times m minus 5 squared minus 4 times m minus 5 minus 15. Okay, let's let x equal m minus 5. And so what we now have is 4x squared minus 4x minus 15. Now, if you multiply these together, we're going to get negative 60. Because it's negative, we're looking for factors that give us a difference of 4. And you can start listing these if you want. Otherwise, you can jump right to it if you see it. And that looks like, I'm going to stop right there because that's it, right? And we need the 10 to be negative and the 6 to be positive in order for it to add up to a negative 4. And these still product would be 60. So I can go 4x squared plus 6x minus 10x minus 15. And if I group those together, I can take out a 2x. And it leaves behind, a 2x plus 3. So I'll leave a big space and I'll put 2x plus 3 down again, because whatever I leave behind here, I have to leave behind here. Then I'll think about what I need to put here so that when I distribute, I get back to those things. And it's a minus 5. So I end up with 2x plus 3 times 2x minus 5. But I can't stop here because there's no x in the problem. I have to re-substitute x for m minus 5. So what I've got is 2 times x, which is m minus 5, plus 3 in the first one, and 2 times x, which is, again, m minus 5, minus 5 in the second thing. And I'll distribute this, and we'll get 2m minus 10 plus 3. We'll distribute this, we'll get 2m minus 10 minus 5. And when I simplify that, I'm going to get 2m minus 7 times 2m minus 15. And that's your final answer. Okay, number 41 says 3 times m plus p squared minus 7 times m plus p minus 20. So again, I'm going to let x equal m plus p. And then what I've got is 3x squared minus 7x minus 20. And if I multiply these on the outside, I'm going to get negative 60. Because it's negative, I'm looking for factors that give me a difference of 7. So you can just start listing the factors: 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12. And I'm going to stop right there because that's it. Those give me a difference of 7. So I'll put the negative on the 12 and the positive on the 5 because I have to add up to a negative 7. And again, these multiply to that. So I'll rewrite this as 3x squared plus 5x minus 12x minus 20. Those are my 7x, right? And I can group these two as if they're a separate problem by taking out a 3x. And that leaves behind, I'm sorry, not a 3x, just an x. And that leaves behind 3x plus 5. So I'll leave a big space and I'll put 3x plus 5 down again. Then I'll think about what I need to put here so that when I distribute, I get back to those items. That's a negative 4. So my common factor is 3x plus 5, so I pull that out, and I'm left with x minus 4. But I can't stop here because there's no x here. I have to resubstitute m plus p. So I'm going to have 3 times m plus p plus 5 here in the first parentheses, and simply m plus p minus 4 in the second parentheses. I'll distribute this and we'll get 3m plus 3p plus 5 in the first parentheses, and this cannot simplify. That's it. But that was number 41. Okay, number 45 is 2x to the 4 minus 9x squared minus 18. Okay, I'll multiply my outer two numbers together, get negative 36. I'm looking for factors that have a difference of 4. So if you don't see them right off the bat, just start factoring it. I'm going to stop there because that does it. Okay, so put the negative on the 12 and the positive on the 3 because they have to add up to a negative 9. So this middle term, I'm going to have 2x to the 4 plus 3x squared minus 12x squared minus 18. This is my 9x squared. I just broke it up based off of these factors. Then I'm going to factor those two by taking on an x squared. And we'll have a 2x squared plus 3. So I'll leave a big space and I'll put 2x squared plus 3 down again because whatever you leave behind here, you have to leave behind there. Then I'll think about what has to go here so that when I distribute, I get back to those. And it's a negative 6. So I'm going to end up with 2x squared plus 3 as the common factor times x squared minus 6. And that's it. Okay, last one, number 47. We've got 16x to the 4 plus 16x squared plus 3. If I multiply my two outer numbers together, I get a positive 48. I'm looking for, because it's positive, I'm looking for factors that add up to this. So if you don't see them, just start doing this. 24, 3 and 16, 4 and 12, 5 doesn't go in, 6 and 8, and I guess that's it. So I'm looking for something that adds up to 16. I guess there it is. I could have stopped there. And they both got to be positive. So I'm going to break up this middle number with those. So I'll have, this is plus 4x squared plus 12x squared plus 3. These numbers are my 16x squared. And I'll break up that by taking out a 4x squared. And I'll be left with a 4x squared plus 1. So I'm going to leave a 4x squared plus 1 over here again because whatever I leave behind here has to be there. Then I'll think about what goes here so that when I distribute it, I get back to those. It looks like a positive 3. So my final answer is the 4x squared term that's in common times my 4x squared plus 3. And that's it.